Good morning, friends. Last time we were discussing about LC synthesis. We got stuck in a little problem. See, we had Z11S, there was a slip we made. We had something like this, S squared plus 16 plus K3 by S. So, while removing the pole partially, we are concentrating on K1S. Instead of that, it should have been in K3S. Okay, and from there you will get the value of K1 dashed corresponding to the one that is to be removed, K3 dashed. Okay, and you will get the pole shifted. So, I would leave it to you for completion of this. After that, it is a very straightforward method. We will take up today RC networks. All right. RL is not used so often because of the imperfection in the inductance L. So, RC is a very commonly used network. So, we will concentrate on RC network. Before we go to RC network in details, we would like to see the properties of ZS and YS. Some of the properties of ZS and YS which we did not study earlier. We will see what would be their plot in the S domain. Suppose we consider the ZS function, it may be S plus 2. Let me take a very simple example, S plus 5 divided by S into S plus 4. The pole is at the origin. So, 2, 4, 5. What would be the impedance diagram? Z sigma. If I put S is equal to sigma, that is minus 2, minus 4, minus 5, these are the poles and zeros, and if I put any other value of sigma, what would be the nature of variation at least near these poles and zeros? It will be a pole here passing through 0, this is a pole. So, it will be from infinity passing through 0, it will be going to infinity. Okay. Again from here it will be going like this. At S equal to infinity, it is finite. Okay. Let us see, if you put S is equal to infinity, it is S squared by S squared, that is 1. In this particular case, it is 1. Had there been a constant here, it would have been that constant. So, this is Z infinity at S equal to infinity. Why should the slope be negative? Slope, should it be negative? Let us find out d sigma of, see, this can be written in a general term, some Ki by S plus Pi. Okay, summation of this. Pi may be 0, in that case the pole is at the origin, otherwise the poles are at points like 4, there can be many more poles. So, this is a general term. So, we will differentiate any of the general terms and see what will be the nature. S is equal to sigma. Okay, we are putting S is equal to sigma. So, you will find this will be giving me minus Ki by sigma plus Pi whole square, which will be always giving me a negative slope. All right, this is irrespective of the value of sigma. So, here it has to pass through 0 with a negative slope. So, the curve has to be this way. All right. So, this is the nature of Z in case of an RC network. Had there been a pole somewhere other than the origin and so on, what would be the nature of this? This is a pole, all right. This is a pole this is a 0, this is a pole, okay, this is a 0, what about this one? So, it may cross at a point z at 0, all right. Let us have a function like zs equal to, so this is at -1, so s plus 1 into s plus 2, s plus 3, I am just arbitrarily taking some points, okay. So, this is 1, this is 3, this is 2, this is 5. We may have a function like this. What would be z0 if I put s is equal to 0? So, it is 10 by 3. What is z infinity? So, z0 is always greater than z infinity. Are you convinced? Is there any logic for it? When I put s is equal to 0, see these are poles and zeros, starting with a lower value, a pole first, that means 1, then the 0 corresponding 0 will be at a higher point. So, 1, 2, the ratio is always greater than 1, 0 is always above the pole, all right. Here it is 5 by 3 and so on. So, z0 will be always more than z infinity. It can be under a certain situation, it may be equal to,
like s plus 3, s plus 2, s plus 6, s plus 1.
okay. Let us see, s plus 3 into s plus 2, then the poles and zeros are not interlacing, it will be an RLC circuit, it will not be an RC circuit. So, because of the property that RC networks will have poles and zeros coming alternately, starting with a pole, that means the lowest value is a pole, then a 0, then a pole, a 0, 0 is always at a higher point than a pole. So, the ratio is always greater than 1. So, the overall ratio is more than 1, and if you take s tending to infinity, that gives me z infinity, which will be s squared by s squared, that is 1 at the most, all right. Otherwise, it will be 0.
So this rule does not have exceptions?
No, for an RC network it cannot be otherwise, it cannot be otherwise. So, z infinity is 1 in this particular case, otherwise if you have a k, both of them will be multiplied by k, okay. So, this is an important conclusion, z naught is always greater than z infinity in case of an RC network. For ys it will be just the other way around. So, for ys, for an RC network, z0 sorry y0 is less than y infinity, and the slopes will be positive, okay. So, if we take an admittance function, it will look like this. Say ys is, once again I can put it as -1, -3, okay, s plus 4. So, this is an admittance function of an RC network, okay. What would be y0? 3 by 10,
3 by 8.
so, sorry 3 by 8, 3 by 8. So, it will be somewhere here, then from here and so on. Then at s equal to infinity, it is 1, this is much above this point. So, how will it move? It will be going to infinity like this. Asymptotically it will go to y infinity, that is equal to 1. Is that all right? Now, suppose there are these following steps of removal of poles. Okay. Part removal, I can have a partial removal of a constant from Z. If you are given the specification in terms of ZS, you remove a constant ZS which will be some Kp times Z at infinity. Okay. See, for Z, Z infinity was like this. Okay. So, some fraction of it I can remove. I do not remove Z infinity totally. What is Z infinity? Z infinity, what will it give me here? Now, in this particular example, it is 1. If I make partial fraction of this, it is K1 by S plus K2 by S plus 4 plus a constant K3. So, at S equal to infinity, this will vanish, it is this term, all right, it is this term which is partly removed. That means, whatever is that constant, I do not remove it totally, I retain a part of it, all right. So, if I remove a part of it, what happens to the zeros? What happens to the zeros? So, let us go back to that very example. ZS is S plus 2 into S plus 5 divided by S into S plus 4. So, if you make a partial fraction, K1 by S plus K2 by S plus 4 plus K3, that gives me 1 plus 5 by 2 S plus 1 by 2 into S plus 4. You can calculate K1, K2, K3 as 1, 5 by 2 and half. All right. Suppose I remove only a part of it, half of it, 50%. Then what will be my new ZS is half plus some Z1S. What will be this Z1S? It will be the balance half plus 5 by 2S plus 1 by 2 into S plus 4. Okay. Now, can you see the result? And that gives me, just check up your calculations, 1 by 2S. So, S into S plus 4, so S squared plus 4S plus 5 into S plus 4, so 5S plus 20 plus S. So, that gives me 5 plus 4, 9 plus 1, 10S, S squared plus 10S plus 20 by 2S into S plus 4. Okay. So, that gives me minus 10 plus minus root over 10 square minus 80. So, by 2. So, that gives me minus 5 plus minus root 20 by 2, root 20 is how much? Root 5. So, 2.24. Okay. So, it is S plus 7.24 into approximately S plus 2.76 divided by 2s into s plus 4. So, what will be the pole 0 configuration? Earlier we are having a pole, okay, at 2 there was a 0, at 4 there was a pole, at 5 there was a 0. Now, this is for ZS. I am not drawing the entire sketch, I am just showing the pole 0 configuration, and at Z1 now we have got a pole here, a 0 at 2.76 here, pole here, and a 0 at 7.26. You see the shift in the 0 positions. Is it all right? So, if you weaken the what you have done is you have partly removed this. What is this part removal? Part removal of y at infinity, z at infinity, z at infinity. Z at infinity, this has been partly removed. So, if I remove it partly, you see the intersection of this is now taking place here, intersection of this is taking place here. So, this is the new shifted position of the zeros, all right. If I remove it partly, then if I draw a line, these are the new zeros, okay. Not convinced? Z1s, let me write Zs minus Kp into Z at infinity. Do you all agree? So, we are, suppose this is the new location of the 0, at that location Z at that location new 0, I call it Z1s, Z1, Z2, okay, and so on. This is 0. So, this is 0. So, Z at that point should be equal to Kp into Z at infinity. So, Kp into Z at infinity, Kp into Z at infinity is this, that value should match with this function at various points at those zeros. So, this is the shift. Wherever this condition is satisfied, those ones will be Z1 or Z2 or Z3. So, these are the Z1s, Z2s, etc. Is that all right? So, this is the condition to be met to determine what should be the value of Kp to get a particular location of Z1 or Z2. That means, the desired 0, the shift in the position of the 0 at the desired position at Z1 or Z2 we can achieve by equating Z at that point equal to Kp into Z at infinity. So, that gives me the value of Kp, the fraction of this to be removed. Okay. If instead you remove, okay, we had, once again I will start from the same function, Zs is equal to 1 plus 5 by 2s plus 1 by 2 into s plus 4. Suppose we weaken this one partly, this pole, what happens? So, Z1s will be 1 plus, suppose we remove 50% of it. So, 5 by 4 we retain plus 1 by 2 into s plus 4. Okay. If you take 50% of it, 5 by 4s, and remaining 5 by 4s is here. So, it will be 4s into s plus 4, 4s plus 5 plus 2, correct me if I am wrong, 4 into s plus 7 by 4 divided by 4 into s plus 4. So, 4 gets cancelled. So, once again, if we sketch the poles and zeros, 4s plus, sorry, this is totally wrong. Yes, this is 4s into s plus 4. Thank you. This is all right? No, nothing is right. Okay, let me work it out. 4s into s plus 4. So, one is 4s into s plus 4. So, 4s squared plus 16s plus
5s plus 20.
4s squared plus 16s plus 5 into s plus 4. So, 5s plus 20 plus 2s. Is that all right? So, that gives me 4s squared plus 21 plus 1 2 23s. Is that so? Plus 20 divided by 4s into s plus 4. Then why have you left the factorization for me? Tell me the values. It will be minus 23 plus minus root over 23 square 529 minus 4 into 20 320, okay, divided by 8. So, minus 23 plus minus 529 minus 320. So, 209 14.5 divided by 8 approximately. So, 23 and 14, how much? 37.85 by 8. So, this is one root. So, 4.75 approximately, and the other one is 23. So, this is approximately 8, okay, it's a little more than 1, okay. So, let us take as minus 1 and minus 1.1 or 2, whatever it is. This was 1, 2, then 4, then 5. Now, it is minus 1 minus 4.75 . We have weakened this pole at the origin, is it not? So, this 0 is drifting to this side, this 0 also drifts towards this side. That means, all the zeros will be gravitating towards the 0, towards the pole which you are weakening, all right. Here both of them will be shifting towards origin. Let us weaken the third one and then see what happens. Z1s is equal to 1 plus 5 by 2s plus 1 by 4 into s plus 4. Half of this is removed. So, 1/4 I have taken out. So, 1/4 is retained. So, this will be how much? 4s squared plus 16s plus 5 into 2, 5 into 2s. So, 10s plus 40 plus s. So, that gives me 4s squared plus 26 plus 27s plus 40 divided by 4s into s plus 4. So, that gives me minus 27 plus minus 27 square 729 minus 4 into 4 into 4 640, okay, divided by 8. Is that so? 729 and 40. So, this is 81. 89. So this will be 9 point how much? 9.4 divided by 8. So 36.4 by 8, say 4.5, 4.52. This is one root. The other one is 27 minus 9, 18 by 8, little less than 2, little more than 2. Okay, approximately minus 2. This is an approximation, a little less than 2. So it will be S plus the poles and zeros, these are somewhat approximate. This is the minus 2 point. You should tell me this is a little less than 27 minus 9, 18. Okay, 2.2 minus 2.2. Let me see. I hope these calculations are all right. Then what was the pole at? Minus 4. Then it was at 5. This was Z, and Z1, this is a pole, this is a pole. So 2 becomes 2.2 and this 5 becomes 4.5. You see, now both of them are coming towards this pole. So the shifts are in opposite directions, but they are towards the pole. This is what I wanted to stress. That means the pole that you are weakening will be attracting the zeros from their earlier positions towards that particular pole itself. So the movement of the zeros are known. So once you know this, then the problem is simplified. You know which zero is to be created by weakening which pole. Yes, please. Any question?
Weaken the pole so much that the zeros become poles. Like from both ends.
No, well, zeros become poles means zeros will be merging with a pole and they will vanish.
Yeah.
So that is a total removal. That's what you precisely do. When you take out that pole totally, there is no trace of that pole in the remaining part. All right. So it is like a positive charge and negative charge. When they join together, that becomes neutral. So when the zero merges with the pole, means the pole is totally removed. So we have seen the three cases of removal of partial removal of a pole at the origin or at any definite location, or removing the constant. In case of y, what would be the effect on partial removal of, say, any pole or constant? In case of y, where will be this value? This value is more or less than this infinite value. Sorry. There can be many more such segments and so on. This value is always greater than this value. So here you remove a part of this constant. All right. Earlier case you removed part of this constant, and then again you will get zeros shifted. let us take up an example. You are given y22 as s plus 1 into s plus 3 divided by s plus 2 into s plus 4, okay. Minus y12 is given as s into s plus half divided by s plus 2 into s plus 4, all right. So, if you look at the poles and zeros, I will just sketch it here, only the poles and zeros. At 1 you have a 0, this is for y22, then at 2 you have a pole, at minus 3 you have a 0, at minus 4 you have a pole, and you want y for y12, there is a 0 at the origin, there is a pole, sorry, 0 at half, there is a pole at this point, there is a pole at this point, okay. In the original one, this will be the nature of pole 0, this is the impedance diagram, is it not, admittance diagram for y22. So, it is part of this that I am going to remove, part of this, maybe this much I remove. If I remove this much, then this will be the new 0 location, is that all right? If I remove it totally, then this 0 will come here, is that so? Mind you, there is no pole I am weakening, it is removal of a constant. I can remove part of a constant or weaken any pole, all right. That pole, depending on the network function, that pole can be at a finite point or at infinity or at 0, depending on whether it is an admittance function or an impedance function. For an impedance function, RC impedance function, the pole can be at the origin, but there cannot be any pole at infinity. Similarly, for an admittance function, pole can be at infinity, but not at 0. First one has to be a 0. So, I can remove a part of that constant value, okay, whenever it hits the s equal to 0 line, all right, a part of that is removed. So, if I remove that, wherever it hits this curve, that is the shifted 0 position. I can remove it totally, and then this 0 can be brought here. So, let us take up this particular problem. So, y22, if you make a partial fraction, it gives me 3 by 8 plus dot 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 plus y1s, let us call it y1s, the remaining part. I am interested only in the constant part, I am playing with this first. So, what will be y1s? y1s is y22 minus 3 by 8. So, that gives me 5 by 8. y22 is this much, s plus 1, s plus 3 by s plus 2 into s plus 4. So, I am subtracting 3 by 8 from here. 3 by 8 is actually the constant value. Suppose I remove that constant, then what is left? y1s becomes 5 by 8 into, you can make partial fractions and then add also rest of the terms, or subtract directly, s into s plus 14 by 5 divided by, just worked it out here, s plus 1 into s plus 3 by s plus 2 into s plus 4, and I am subtracting that y at 0 value. which is equal to 3 by 8. So, minus 3 by 8. So, that gives me 8 into s plus 2 into s plus 4. Okay. So, 8, how much is it if you subtract 3 by 8? Are you getting any minus sign? Eight into s plus 1 into s plus 3 minus 3 into s plus 2 into s plus 4. So, that gives me 8 s squared minus 3 s squared, 5 s squared plus 3 plus 1 4 into 8 32, 4 plus 2 6 into 3 18, 32 minus 18 14 s plus 3 into 8 and 3 into 8, okay, divided by 8 into s plus 2 into s plus 4, which gives me this one. 5 by 8, if you take common, it will be s plus 14 by 5. Is that okay? So, what would be the zeros for this? y1s, I have realized 1 0. I have removed it completely. So, this will be, if I remove it completely, this will be hitting here only, is it not? So, I will get a 0 here, and that is one of the desired zeros. I could have realized partly and got into this 0. Okay. Either you realize this 0 first or this 0 first, you take one at a time. Okay. So, if I remove it partly, I could have got at minus half this one. If I remove it totally, that is this part 5 by 8, 3 by 8, then you can go here. Can you tell me what would be the value of that partial removal of this constant 3 by 8 such that I realize this 0? Can you all try? Let us see that also. So, now I have got a 0 here and 0 at minus 14 by 5 and pole at 2, then pole at 3, minus 2 minus 3 and sorry a 0 pole at minus 4, no 0 here. Okay. This is my new distribution of the pole 0 for the balance function y1. If instead of realizing y1s like this, suppose we take 50% of it or a certain percentage of it, so that we get the 0 at s equal to half, minus half, then what would be that value of the removed material? Okay. So, y22 minus some kp times, this is partially removed constant which is less than 1, times the actual value is 3 by 8, that should be equal to my new y1s, and this must be equal to 0 at s equal to minus half. So, y22 at minus half, how much is it? That means y22 at minus half minus kp into 3 by 8 should be equal to 0. So, kp is y22 at minus half divided by 3 by 8. So, how much is that? Y22 at minus half, y22 at minus half is half into 5 by 2 divided by 3 by 2 into 7 by 2 divided by 3 by 8. So, 2 goes. So, 5 by 21 into 8 by 3. How come you are getting 40 by 63? This is kp. Is that all right? So, if this fraction of 3 by 8, that means 5 by 21 would have been removed, I would have got a 0 created at minus half. Once you have realized a 0, then what would have been the factor of y1? y1s would have been s plus half as a factor, a 0 created there, multiplied by, I do not know, that you have to calculate out, but I am sure s plus half will be one of the factors, and the denominator as it is s plus 2 into s plus 4. Okay. So, after you have realized a 0 at a particular location, how to realize the network element, how to get rid of it? Whenever there is a 0, how do you remove that 0? Invert it, create a pole, make partial fraction and remove that, is it not? So, from ys we have to go to corresponding zs. So, z1s, so let us go back to the first realization when you have shifted the 0 to the origin, that is totally removed that factor 3 by 8, all right. 3 by 8 is removed from y. What does it mean? We have started from the terminal 2 dashed, okay. We have started from the terminal 2 dashed, and then we have started from here. We have started with a first element which is a resistance. 3 by 8 is a constant, all right, that I have removed. y22 is equal to 3 by 8 plus y1s. So, 3 by 8 is the admittance. So, 8 by 3 ohms resistance I have put, and this is the balance y1s, okay, yet to be realized. Now, we have seen that there is a 0 at the origin. So, from y1 we go to a corresponding z1 because we want to realize that 0. So, what will be the corresponding z1? This was our, after removal of that constant, this was our y1. So, z1 corresponding z1 will be 8 by 5 s plus 2 into s plus 4 by s into s plus 14 by 5. Okay. So, remove this as k1 by s plus whatever is left over, I call it z2. Okay. So, get rid of this 0 which has been realized as a pole. So, how much is k1? Multiply by s, make s equal to 0. So, 64 divided by 5 into 14 by 5. So, 14, 64 by 14, 32 by 7, all right. So, 32 by 7, this y I have converted to a z. All right, I am writing in the form of a z whose series element is 32 by 7. What? Sorry, this is k1. So, 32 by 7 s, k1 by s means 32 by 7 s. So, what is it? A capacitor 7 by 32 farads. Okay. Whatever is remaining, I call this as Z2. All right. This Z2, I have to finally calculate Z2. So, how much is Z2? Once you have written 32 by 7 S from Z1. So, 8 by 5 into S plus 2 into S plus 4 divided by S into S plus 14 by 5 minus 32 by 7 S. If I remove this, I will get the balance. The other alternative is, you can make partial fractions. Since there are only 2 poles, you can make partial fractions. Remove that, one of them will be 32 by 7s. So, remove that, whatever is remaining will be your Z2. Okay. So, how much is it? How much is it coming to? Okay, let us compute. I have got 8 by 5 Z1 as 8 by 5 into S plus 2 into S plus 4 divided by S into S plus 14 by 5. I could have written as K1 by S. This is the one which I have removed. K2 by S plus 14 by 5 plus K3. Okay. And that gives me, this is not to be calculated, K2 S plus 14 by 5. If I multiply by this, make S equal to minus 14 by 5. So, 8 by 5, 8 by 5, S plus 14 by 5. So, 4 by 5 minus 4 by 5. Correct me if I am wrong. 14 by 5 and 4, 20 minus 4, 6 by 5 divided by minus 14 by 5. So, that gives me 8 by 25. Is that so? 24 by 14. So, 112 by 175. Okay. So, it is 100 and this K2 is this much. How much is K3? K3, make S tending to infinity. So, it will be 8 by 5. So, basically 112 by 175 into S plus 14 by 5 plus 8 by 5, this total sum will be your Z2, is it not? This will be equal to Z2, is that all right? So, from Z2 what should you do? From Z2 what do you do? Again go back to Y2, then again weaken a pole so as to realize the other 0, so as to realize the other 0, that is at minus half. So, if you keep on doing it, so you have to remove partly one of the poles so that the 0 shifts to minus half. Again realize it by taking a factor 1 by S plus half, by inverting it and making the partial fraction. So, if you keep on doing it, you finally get, I will give you only the final result, you can work it out, this procedure is same. Alternately you have to go for impedance and admittance. So, you get next stage you will get Z3 as 37 by 3 after removal of this, S plus 22 by 7 by S plus half. Okay. Means in the next stage, after realizing that new 0, invert it, you get the pole and then again make partial fractions. So, the final values will be like this. It is 296 by 161. Okay. Then a capacitor. In the final stage, you may have, since it is going to be realized as S plus half, K by S plus half, it is an RC combination. All right. Earlier we are getting a factor like K by S, we removed 32 by 7 S, is it not? So, that was a capacitor. Now, it is an RC combination. So, you will get something like this, okay. That will give you S plus half. Then because that Z, this one will be this RC combination and a constant, that is all. Y22 is an open circuit parameter or short circuit parameter? It is a short circuit parameter. You will be shorting this. So, measuring the impedance from here, you will get the same impedance, that admittance, sorry. Okay. Is this point clear? The last one is from Y3 I have got Z3, say from Y3 where you have got some factors here divided by some factors here, and you want to remove that much of a constant, so that you get in the next stage, say Y4, something like S plus half realized here. Okay. So, you have removed Y3 as Y4 plus a constant which was 296 by 161. This constant was decided so as to realize S plus half in Y4, is it not, the other 0. Once you have realized that, that factor became, if I invert it, that factor became this, is it all right, this part. This was basically S plus half into S plus 22 by 7 into 3 by 37. It is this one which was inverted and you got this. So, after realizing this resistance, whatever is left over, you invert it, that will be the Z, and that is just a simple RC and R combination. So, you leave it there. So, this will be your Y22 and Y12 specification made. Obviously, Y11 can be anything, there is no unique choice. I could have removed that 0 at minus half earlier. So, I could have got something else. This RC combination could have been at the beginning itself. Do you get my point? So, we will stop here for today. Next time we will take up lattice synthesis. Okay. Good afternoon, friends. Today we shall be discussing about symmetrical network, symmetrical lattice network. For two-port synthesis. Let us take a simple network function in this form. ZA is an impedance, ZB is this impedance, and similarly you have ZA here and ZB here. Now, what will be for this network, what will be Z11 and Z12 in terms of ZA and ZB? We shall be, see the symmetry, we shall be denoting this henceforth by an impedance ZA and ZB, okay. And it is understood by these dotted lines we denote the other two counterparts. This is ZA and this is ZB. So, we shall be showing only by dotted lines. Now, what will be Z11 and Z12? If you look at this network, see one side is ZA and ZB. So, I can show from one, say I can show it like this, ZA and ZB. Okay. The junction is 1, ZA and ZB. Okay. From ZA, the junction of ZA and ZB, this is 2. There is another branch ZB and ZA. And that junction is 2 dashed. So, basically this is 1 dashed. If you look at it, 1 dashed by 4 is equal to 1 plus ZB minus ZA squared by 4. Equate ZA square ZB square will get cancelled. So, you are left with twice ZA ZB. So, ZA ZB by 2. Okay. If I bring it to this side, then A plus B whole square minus A minus B whole square, that will give you 4AB. That divided by 4 is just AB. Okay, thank you. ZA ZB comes out to be therefore 1. So, if you want that the network, we are planning to have a network which, if terminated by a resistance R, let us take a normalized situation 1 ohm, then the impedance in from this side is also 1 ohm. What will be that ZA and ZB? Now, ZA and ZB must be at this relation, ZA ZB is equal to 1. So, in the next class we will start from here. This is for a normalized relation. If it is equal to any R, ZA ZB should be equal to R squared. So, ZA ZB should be equal to R squared. That you can see from here itself. If you would have put R here, would have got R squared. So, in general ZA ZB should be equal to R squared. Once you select ZA, automatically ZB is fixed. For such lattice network, terminating impedance R will generate an impedance of R from the looking inside. Thank you very much.